In this video, we will take a number from a register. Now the number we're going to choose is 41 in hex, which is actually 65 in decimal. And 65 in the ASCII character set is a capital A. So we're going to take a number from the register and we're going to take it and we're going to display the ASCII equivalent of that on the display here. So we should see a letter A appearing. Now, before we do that, we're going to have to work out what the actual commands are going to be. So again, we can get this in the spreadsheet. And as I mentioned before, I do actually have an assembler, so we don't really need to use this spreadsheet. But for the moment, I haven't introduced the assembler, so we will do it like this just for this video. Okay. So what we want to do is we want to place a value from a register into memory. So a register to memory is a store command. So we're going to go from, first of all, a register into a memory location. So we can use this term here, this instruction, store RA, 10, okay? But in this case here, our value of 10 is going to be replaced by the value of the memory location which is mapped to the display through our memory mapped IO. So in this instance here, the value is 8 in hex, so that's 08, and we're going to go from register RA. So register RA, we'll say it's register 0, okay? So that'll just be the value 0. And the destination, we don't care, it's a 0 as well. So we're going to have 0800 for the actual store command. But before we do that, we're going to have to actually place the value that we want to move from the register into the display, and that value is a value of 41 in hex. So we have to put that in first of all into the register. So we're going to have the commands which will be put into the RAM. So this is the RAM here, and I'll make it a little bit bigger and I'll shift it over a wee bit so that you can see it. So the values that you're going to put into the RAM, well, first of all, it's going to be the data command to get the value 41, okay? So the data command is 01 and it will be register R0, so it's 00. And we're going to have the value 0041. So we're putting the value 41 into register R0, which represents the ASCII value for character A. Now, once we've put that in there, what we want to do is we want to do our store command, which is 0800, and we have to point to the memory location for our display. So the memory location for the display, as I mentioned in the last video, is going to be FFF3. And then we can finish off by putting in the 5800. So that's our little bit of code that we want to run through. So let me fix this screen again, and then we will go to the top level and we'll work through the actual program here. So I'll click through at the moment, and again we're going to see the stack pointer get set for FFF0. We're then going to jump to the position 8000, which is the start address of our program in the RAM. We're then going to take the first command, which is the 100, which is the data, and it adds the value 41 into register R0. So we have the ASCII value A, capital A, sitting in R0. We're then going to go ahead to the next command, which is the 0800, and it's going to point it to the actual keyboard. So we can actually see it pointing. So let's try this point here. We'll see if we can see it actually pointing to the keyboard. So we can see here that the enable has gone high, and if we were to come in here to the display, you'll see that the enable has gone high and we're now pointing to this keyboard. So we're pointing to the keyboard. All we're waiting for is the clock set to come along in order to pass this value to the output. So whenever we work through the next part of this, which is the clock set, we should see the value A coming on the keyboard, on the display. And let's have a look and see. So there it is there. So you can see the A has just appeared. So we'll finish this code off just to we get to the very end. And that's the very end. And you can see if I zoom in, we have the character A on the display. So we've gone from the register to the display, and the display has interpreted the value in the register as an ASCII value for 41, which is the capital A. Now we can do the same but going from a memory location. So we want to be able to save a value 41 in a memory location and then drag it from the memory location out into the display and display it that way. So let's just do that now. Now there are a couple of different ways that we can take the ASCII code from memory and have the character on the display. Now one of them is to again use the store command, but what we would have to do is take the value from the memory and then take it into the register and then go through the same process. From the register we can then place the value onto the memory location, which is memory mapped to the display. So we would have to go from memory into the register and then register back to memory. So we can do that, and I have done that on several occasions, but there is another way that we can do it. We can utilize one of our other commands. So if I head in here, you'll see that we actually have a move command here, which allows us to move information from one memory location to another memory location. So here we have move 10, 20. So we're moving the contents from memory location 10 to memory location 20. So we could move the contents of a memory location which contains the value 41, which is the ASCII for A, and we could move that to the memory location FFF3, which from our memory mapped IO will then put that out onto the display via our output buffer. So let's go ahead and we will put this one in. Now you know that the actual code for that is 1C, and it's don't care. So it's 1C00 will do that move for us. So let's go ahead and we'll put these values in. So again, we're going into the RAM here, and I'll zoom in a little bit and shift it over so you can actually see the values going in. So in our RAM, we're going to have to put in our value 1C00. So we're going to have 1C00. So that is our data command, and we want to move, well, we want to move the contents of a memory location. So let's pick this memory location here, and let's say this memory location contains 0041. Okay, so that's our ASCII value for the character capital A. And we want to move the contents of this memory location. So remember, this memory location is actually 800C. Okay, now what we're doing here at the moment, we're having to understand how the memory is all set up, but whenever we use the the assembler, all this will be done for us in the background and we won't have to bother about any of this, okay? So that's the memory location, but we want to take the contents of that memory location and we want to place it in our display. So the display is going to be at memory location FFF3. And then finally what we want to do is just end the program. So the end is 5800. So that's a little bit of code that will allow us to display the value A from the memory into the display unit. So let me just fix this back again and we will go back into the top level and we'll run through the actual example. Now I won't go through the entire code here. You can always have a look and see the move command because it's one of the more complicated ones, and you can have a look at that within the spreadsheet. So again, we set up the stack pointer, we then jump to memory location 8000, which is the beginning of our RAM, and then we take our 1C00, which is our move command, and we take the value 41, so that's what we want to move, and we've got the here in the index register, which we can use here as a temporary register, and we put the value FFF3. Now this is a thing to note, there's a couple of commands that we have to use other registers. Now we're not bothered the fact that it uses R6 because R6 is a temp register and we don't really have access to that to write. So it doesn't matter if we write over it and continue writing over it. We don't have access to R6 temp via our instruction set, but we do have access to the index register. So I will have to take a note of this within the instruction set architecture, that the instruction for the move command will overwrite whatever is in the index. So that's something we would have to be careful about, because we could have a piece of code that was using the index register and then we do a move command, and then the move command comes in and it changes the index register or corrupts it. Now what we could do to stop that, within the move command we could take the value that's in the index register, we could take it out and put it in the stack, and then we could run through the move command, and when it's finished we could take that value out of the stack and put it back into the index register, and at that point the index register will not have been overwritten, we will have saved it. So that's something that I could do to extend that. Now I've already got about 11 different lines in order to generate that move command, so I may well just have enough. I've got another 5 left, so I may have enough lines left in order to put that value into the stack. So it would be a close run thing, I think, but I'll leave it for the moment. So let's continue with this. And you can see it's actually went through and it's placed the value of A in the display. So I'll just finish this off and it'll go through to the 58,000, and that's the end of the code. And if I zoom in, you can see we've got the character A. So if we were bothered about the possibility of using the index register and overwriting the index register, we could just not bother with the move command and we could use the store command, in which case we have to bring the contents from the memory into the register and then from the register back out to the memory. Or I could go ahead and update the move command so that it doesn't overwrite the index register, and I do that by taking the index register and putting the value into the stack and then pulling it out of the stack whenever that code is actually, that instruction has already been run. So anyway, that's all for this video. We can now take a value from a keyboard and we can put the value from the keyboard into a register, or we can take the value from a keyboard and we can put the value into memory. And then we can take the value from a memory or a register back out into the display. So we've got a process of bringing information from the keyboard onto the display. Now we'll talk about more about that later. The next lot of videos are going to cover the graphics unit, and the graphics unit is a bit more complicated than the display and keyboard. So thank you for listening. I'll get you on the next video. Goodbye.